We will now evaluate this integral and verify the result by differentiation. So first let's consider f of t as the function which is inside the integral. So here we have this f of t equal to 2t squared minus 1 raised to the power of 2. So this is equal to 2t squared minus 1 multiplied with itself, that is 2t squared minus 1. So let's FOIL this out and get this simplified. So I'm going to FOIL this out, which is 2t squared times of 2t squared. This is equal to 4t power 4. And then I multiply the 2t squared with negative 1, which is equal to minus 2t squared. Now I multiply negative 1 with 2t squared, which is negative 2t squared. And finally I multiply this negative 1 and negative 1, which is positive 1. So let's simplify this. This is equal to 4t power 4 minus 2t square minus 2t square. These two are like terms, so it is minus 4t power 4 plus 1. So basically f of t is this expression 4t power 4. I'm sorry, this is t square minus of 4t square plus 1, which means we have to integrate this and verify the result by differentiation. So let's start off with integrating. So we have 4t power 4 minus 4t square plus 1. We integrate this. The first step, I'm going to split this integral into three parts. That is integration of 4t power 4 dt minus integral of 4t square dt plus integral of 1 dt, like this. And the next step, I'm going to simplify this integral. As you can see this in each integral, I have this 4 here. Similarly, I have this 4 here, which means these two are constant. So I can factor out the constant out of the integral. And then I can rewrite this as 4 times of integral of t power 4 dt minus 4 times of integral of t square dt plus integral of 1 dt, which could be further simplified. Let's apply the integration rule. So we go back and revisit the integration rule. So I'm going to apply this rule as well as this rule. The first rule says the integration of x power n dx is x power n plus 1 divided by n plus 1 plus the constant. And similarly, integration of 1 dx is basically x. So I'm going to apply this. So when I integrate this t power 4, when I apply the power rule, I put this as t raised to the power of 4 plus 1 divided by 4 plus 1. And for the next term, it is 4 times of integration of t squared. So I write down this as t raised to the power of 2 plus 1 divided by 2 plus 1. And we know that integration of 1 dx is x, so which means integration of 1 dt is just t, plus we put the constant of integration c. Now let's simplify this. So this is equal to 4 times of t power 5 divided by 5 minus 4 times of t power 3 divided by 3 plus t plus c. So I can rewrite this as 4t power 5 by 5 minus 4t cube by 3 plus t plus c. So basically this is the result of the integral which we started off with, that is f of t equals 2t squared minus 1 quantity square. So when we do integrate this, we get this result. Let's verify this result by differentiating, and we have to confirm if it gives us back the f of t. So I'm going to differentiate this result. So let me copy the result. So this is basically differentiation of 4t power 5 by 5 minus 4t cube by 3 plus t plus c. In the first step, I'm going to split this differentiation into several parts. That is, I can write down this as d by dt of 4t power 5 by 5 minus d by dt of differentiation of 4t cube by 3 plus the next term is differentiation of t. We write down here, this is differentiation of t plus differentiation of constant. So let's differentiate each term now. We're going to differentiate this terms for this term 4 by 5 as well as this term as well as this term and all the four terms. So for the first term we have 4 by 5 t power 5, which means I can factor out the 4 by 5 and then differentiate only the t power 5. So I write down like this, and for the second term I have 4 by 3 is the constant, so I write down this as d by dt of t cube. And similarly for the third term I can just write down the result of the differentiation, because differentiation of t is basically 1 plus differentiation of constant is 0, so I don't need to put, or I can just remove this. Now let's simplify this further. So this is equivalent to 4 by 5 times of differentiation of t power 5. We can apply the power rule of differentiation, that is differentiation of x power n is n x power n minus 1, as well as differentiation of x is equivalent to 1. So when we apply the power rule to differentiate t power 5, we put the 5 in front and reduce the power by 1, that is t raised to the power of 5 minus 1 minus 4 by 3. I put the 3 in front, t raised to the power of 3 minus 1. We then have plus 1. So this is equal to 4 by 5 times of 5 times of t power 4 minus 4 by 3, 3t power 2 plus 1. We can simplify further. I can cancel this 5 with a 5, and I can cancel this 3 and 3. So this is equal to 4t power 4 minus 4t square plus 1. So this is the result that we got when we differentiated the result of the integration. Let's verify that this is equivalent to f of t, which we started off. 4t power 4 minus 4t square plus 1, and here we have 4t power 4 minus 4t square plus 1. So this is equivalent to f of t, which means when we differentiated the result, we got back f of t. So the integration that we done is correct, and we have also verified the result by differentiation.